All right, welcome to the video. In this section 7.1, we are going to be looking at adding and subtracting polynomials. So each time that we dive into a lesson or dive into a concept, we are going to address the essential question. In this case, the essential question is how can you add and subtract polynomials? First things first, I would say one of the things that we have to be able to do is identify what is a polynomial. So uh, we will get um, we'll get more information that in in different slides, but essentially, what we're doing is we're going to look at different terms of a polynomial and how we can combine those like terms in order to add or subtract. So, the simplest classification of a polynomial is a monomial. All right, a monomial is a one-term polynomial, which means there's no addition or subtraction attached to a specific expression. So 5x squared, negative 1 half xy cubed, 8x cubed, y cubed, and negative 3 are all monomials. They're one term. There's no addition or subtraction um, that's part of the expression. So in this question here, they want you to find the degree, all right? Anytime that they're asking you to find a degree of not just a monomial, but any kind of polynomial, you are going to look at the value of the exponents attached to a variable or multiple variables. Okay, so when you look at the first example, we have 5x squared. That means that we have x is an exponent of 2. That means that this degree of this monomial is 2 because it's x squared. When you look at part B, you got negative 1 half x y cubed. You have two variables. You have a variable x and you have a variable of y. So now you have to look at what degrees are those separate variables at that point. So x, even though you can't see it, it's a degree of 1. Y is a degree of 3. Now, to find the degree of this particular monomial, you just add those exponents together. 1 plus 3, which gives you 4. So this is a fourth degree polynomial. You look at C, same idea. You have two variables. You have x and y. Both of them are powers of 3. So you're just going to take 3 plus 3 and you get 6. Now, the last one, negative 3, has no variables. So essentially what you could kind of, you know, tie this in. If you wanted to put a variable to it, you could say like this is x to the 0 power. And if you remember from past lessons, from other math courses, anything raised to the 0 power is going to be 1, so it's negative 3 times 1, so that's where you get there. But since it's a 0 degree exponent, you have a degree of 0 in that situation. So again, looking at these ones here, first one is going to be 4. The second example is 3 plus 2, which is 5. The third example here is just 1. And the fourth example has no variable, so it is 0. Getting into the core concept, looking at different definitions that are going to help us solve the essential question of how can we add or subtract polynomials. All right, so polynomials, by definition here, it says is a monomial or a sum of monomials. All right, each monomial is called a term. So if you look here, this specific name of this polynomial is a binomial, which means it has two terms. The first term is 5x, the second term is 2. Another specific polynomial name is a trinomial. That means it has three terms, x squared, 5x, and 2. And in this case, you are going to look at being able to find a degree of a polynomial, standard form, and lead coefficient. So if you look at the example below, you have 2x to the third plus x squared minus 5x plus 12. All right, that's a four-term polynomial. All right, it's four terms. To figure out the degree of any specific polynomial, what you were going to do is you were going to only look at the term that has the largest degree. So since my largest degree here is x to the third, that means that this specific example is a third degree polynomial. To write things in standard form, in this case, it's already written in standard form. What you are going to do is you are going to pick the term that has the largest degree, put that in front, and then write terms in decreasing value. So if you look like I got x to the third, x squared, x to the first, no variable is at the end. Anything that has a no variable is considered a constant term. So it's got nothing to do with the value in front of the variable. It's got everything to do with the exponent attached to the variable. And then the final definition here is looking at lead coefficient. Lead coefficient is the number that is attached to the variable with the largest degree. And so this case here, 2 is attached to the x cubed, so my lead coefficient in this case is 2. So looking at this example here, they want you to write 15x minus x cubed plus 3 in standard form. They want you to identify the degree and lead coefficient of the polynomial. So what you're going to look at is, all right, what is the largest exponent? The largest exponent right here is 3, and that's attached to, in this case, the minus x cubed. So negative x to the third is going to be placed in front, and I'm just going to kind of cross that out just to let myself know that it has already been taken care of. The next term in this polynomial with the largest degree after that is 15x. So since 15 is positive, it's going to be a plus 15x. Cross that out, and all I have left is my constant term, which is a plus 3. So that is how we can rewrite this particular polynomial in standard form. So we check that off. Identify the degree. So the degree in this case comes from the largest degree, so it's a third degree polynomial. And the lead coefficient in this case is the value that's attached to the variable, and it just says negative x. Well, anytime it's just the negative, it's a value of 1, so it's negative 1 is our lead coefficient. All right, so here, similar example, rewrite in standard form, identify the degree, and classify each polynomial by the number of terms. So for part A, the classification is it's a one-term polynomial, so it is a monomial. And then looking at in standard form, since it's only one term, that means it is already written in standard form, so that's really nice. Identifying the degree Looking at the variable, it's raised to the fourth power. So we have a degree is 4. Our lead, does it ask for lead coefficient? Nope, it doesn't. It doesn't. So standard form, I'll just rewrite it again. And the classification, since it is one term, we are going to call this a monomial. Looking at part B, our largest exponent degree is 2, so to put this in standard form, it's going to be 5x squared minus x plus 4. Our degree in this case is 2, and the classification, it has 1, 2, 3 terms. 3 terms means that it is a trinomial. And finally, part C here, uh, my largest degree is q to the 5th, and that means I'm going to write 8q here. So that's in standard form. It is a 5th degree polynomial, and since it's 2 terms, it is a binomial. All right, looking here, same idea. Uh, for 5, it looks like it's what, negative. Standard form will be negative 9z plus 4. The degree here is going to be 1, and the classification by the number of terms, it's a binomial. 6, rewriting this in standard form, it's going to be negative t cubed plus t squared minus 10t. And the degree in this case is going to be 3. And since it's 3 terms, it's a trinomial. 7, standard form is going to be x to the 3rd plus 2.8x. It's going to be a 3 degree and 2 terms binomial. All right. So now that we have all of those examples out of the way, now we're going to look at being able to solve the essential question and how we add or subtract polynomials. There are 2 things that you have to keep in mind. One is you can only combine like terms. Like terms means that you can only combine things that have the exact same number of variables or the same variables, and they're raised to the same degree. The next thing you have to do is figure out, is your polynomial an addition problem, or is our polynomial a subtraction problem? All right. You are going to approach it very differently if it is an addition problem or subtraction problem. So if you look at these 2 examples here, A and B, both of these are addition problems. The reason why I know they are addition problems is because I have the plus signs between the 2 parentheses. Okay? If there was a minus in there, it would be a subtraction problem. So here's how I would like you to go about solving this. When it's an addition problem, what you are going to do with the first set of parentheses, you are going to rewrite it as is without the parentheses. So my first set of parentheses for part A is 2x cubed minus 5x squared plus x. Rewrite it how it is. If it's positive, leave it positive. If it's negative, leave it negative. So I got 2x cubed minus 5x squared plus x. So we're basically, our first step is getting it out of the parentheses. The second set of parentheses, because this is an addition problem, you are also going to leave that second set of parentheses the same as well. So if it's positive, leave it positive. If it's negative, leave it negative. So it's 2x squared, so it's plus 2x squared plus x cubed minus 1. So all I have done is taken every term out of the parentheses. From here, what we're going to do is I want to identify the variable that has the largest degree. In this case, it is x to the third. And I have two terms with x to the third. So I have 2x to the third, and I have x to the third. I can combine them because they have the exact same variable raised to the exact same degree. So all you're going to do is add the coefficients together. 2 over here, and there's a 1 with x, so that's going to be 3x to the third. And I like to cross them out just to know that I've taken care of those. Next is x squared. Is there any? There are two of them. Negative 5, positive 2. When I combine those, I get negative 3x squared. Cross it out, cross it out. I have x to the first right there. There is no other x to the first, so I can just leave it by itself, cross it out, and all I have left is my constant value of minus 1, and that is our sum of that particular polynomial expression. Looking at b, same idea. Leave it positive if it's positive, leave it negative if it's negative. Same thing goes for the second set of parentheses because it's an addition problem. So it's going to be plus x squared plus 4x plus 10. My largest degree is 2. So here and here, when I combine those two, it's 3 plus 1, which is 4x squared. Cross it out, cross it out. Here and here, 1 plus 4 is 5, so it's plus 5x. Cross it out, cross it out. And my constant values of negative 6 and positive 10 turn into plus 4. So that is being able to add polynomials. When you have subtraction, you have a minus sign in between the parentheses. So there is one small wrinkle that's different, and that is how you approach the second set of parentheses. So here's how we go about it. So for the first set, you leave it just like you did with addition. If it's positive, leave it positive. If it's negative, leave it negative. 4n squared plus 5. That doesn't change. But now because this is a subtraction problem, what you are going to do to the second set of parentheses is you're going to change the sign of every term in that second set of parentheses. So if it was negative 2n squared, now it's going to be plus 2n squared. If it was positive 2n, it's now minus 2n. Minus 4 is now plus 4. Once you have done that and they are all out of the parentheses, you approach it the exact same way as you did with the addition. Find like terms and simplify it from there. N squared, combine the two, I get 6n squared. I have n to the first, that's the only one, negative 2n, and my constant values of 5 and 4, both positive, so it's going to be plus 9. Looking at b, same thing, 4x squared minus 3x plus 5. That stays the same. Change the sign of the second set. So this is now negative 3x squared. This is now positive x. This is now positive 8. X squared is my largest degree. Combining these, it's going to be 4 minus 3, which is 1. So it's just x squared. Cross out, cross out. Negative 3x and x, that's going to be minus 2x. Cross out, cross out. And my constant values of 5 and 8, which gives me plus 13. All right, so last problem, we have a story problem. We have some illustrations here. So let's take a look at what it says. So it's here, it says a penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomial represents the height in feet of the object after t seconds. So here it says write a polynomial that represents the distance between the penny and the paintbrush after t seconds. All right, so if you think about this, if you took away the variables and then you just concentrated on the height itself and you were trying to say like, okay, well, what's the difference in height between these two objects, the penny and the paintbrush? You're looking at a difference problem because you're just going to take 200 and subtract it by 100. So now that they've involved time in this, you're just going to use this expression and you're going to subtract it by that expression. So essentially, you're just going to take negative 16t squared minus 40t plus 200, put that in parentheses, and subtract it by negative 16t squared plus 100. And you're going to approach it the exact same way as you did in the problems previous. Because it's a subtraction problem, you're going to leave the first set of parentheses the same. If it's positive, leave it positive. If it's negative, leave it negative. And you're going to change the signs of the second set. So this is now positive 16t squared. This is now negative 100. All right, my largest degree in this case is t squared here and here. They just so happen to be opposites because one's negative 16, one's positive 16. So essentially, they just cancel each other out. I'm not going to write down 0 because there's other stuff that I can put in here, but if it didn't, I would have to put 0, but in this case, you don't. T is negative 4, so I got negative 40t. Cross that out, and then I got 200 minus 100, so that's going to be plus 100. So the expression of the distance between the penny and the paintbrush after t seconds is negative 40t plus 100. So the second question says interpret the coefficients of the polynomial in part A. All right, so to interpret this, we're going to say that, all right, let's let t equal 0, which means that the distance between the objects is going to be, we're just substituting 0 in for t, is going to be negative 40 times it by 0 plus 100, which means that negative 40 times 0 is 100, so the answer in this is 100 feet in this case. This means that the object becomes 40 feet closer to each other. This means that the object became 40 feet closer to each other each second. So negative 40 represents the amount that the distance between the object changes each second. So in this case, it's 100 feet away, but after each second it would change because you would drop it and those different formulas would work from there. Okay? So that is being able to add and subtract polynomials. Hope this helps. Till next time.